All right. Hello, folks. It looks like we're having a little bit of stream trouble today. So if it drops out, I apologize, but there might have been a bit of a delay on getting started there. But we're going to go ahead and kick it off. And I'm super excited about what we're going to be showing today. And once again, it looks like the stream is lagging pretty bad today. So there might be a little bit of delay. So feel free to let me know in the chat. But I'm gonna go ahead and kick us off because I think there's a lot we can talk about, and I'm kind of getting back to the original TBS streams where we just had solo shows where myself or other Crossplane folks would host it. And this one, I thought we'd kind of get back to that and look at some of the new features that are coming out in Crossplane 1.1.0, specifically around provider authentication, which is something I worked on for this cycle. And super excited because we think it's going to enable a lot more users to consume cloud provider credentials or credentials to talk to any API in a more secure way. So definitely want to enable folks in that manner. It does look like we have some folks watching on the stream. So it looks like Jared's here. Jared, our most faithful listener and a founder of the Crossplane project, joining from San Diego. Good to see you, Jared. And just as Jared did, please feel free to introduce yourselves, ask questions as we go along. I've also got the Crossplane Slack window open. So if you want to drop in there and send me a direct message, and if you don't want that to be public, I'm happy to answer questions in that way as well. But without any further ado, let's go ahead and jump into it. And since we're just talking about Crossplane today, you folks are probably already pretty familiar with the project if you've watched this stream before. But we will give a little bit of an overview for those who are new. And it looks like Nick is joining. Nick does a lot of developer advocacy and development work over at HashiCorp, and we're going to be talking about Vault today. So thank you for joining, Nick. Super exciting to have you here, and definitely want to have you on the show in the future to talk about some of the further integrations we'll have. But yeah, for folks who are not super familiar with Crossplane already, it is a way to manage infrastructure across cloud providers, on-prem, anywhere from a single control plane on Kubernetes. So you'll see on the front page here, the first thing that folks usually come to Crossplane for is to be able to provision what we call managed resources from the Kubernetes API. So just like you create your pods or deployments or Knative services or certificates or whatever from different operators that you plug into the Kubernetes API, Crossplane's coming along and saying, we'll bring all of those different cloud provider resources that you want to provision and let you do that from Kubernetes. So the other thing that Crossplane does is allows you to provide some abstractions on top of those resources. So I frequently go to this composed infrastructure here because I think it's a really powerful representation. Here you see us provisioning resources on different cloud providers. All looking pretty much exactly the same, right? So this is translating to different services on these various cloud providers, uh, but has some of the common fields like the storage size and that sort of thing. And it's mapping to these cloud providers, giving you an abstraction layer. And we'll talk about how you can expose that at the cluster scope versus namespace scope and different, organizational practices to have good separation of concern and policy management. But basically, you can create these abstractions and define your own cloud provider platform, essentially, or just infrastructure platform if you're using on-prem services as well. And you can have pretty complex things hidden from developers when they're provisioning their infrastructure. But today, I'm actually going to flip over, and some folks aren't aware of this tab, but we have kind of our latest commits here available on the documentation. You'll get this big warning because this isn't available yet. Our 1.10 release is coming on March 2nd, and we actually just added a chart here to show our currently supported releases and our upcoming releases. So you're welcome to look here in our README if you're wondering when things will be supported for or when the next upcoming release is or what the current patch is. We'll keep all of that here. And we should have a blog post also coming out about our post 1.0 release cadence and support cycle. So keep an eye on that as well. But anyway, we're going to look at something that's coming out in the next version of Crossplane. And it's really actually localized to the different providers. So not strictly around the Crossplane release, but around the provider releases that will come with that. And that is the ability to supply credentials to these providers in more ways than you're currently able to. So when you install Crossplane, you typically choose a provider, whether it's one of these cloud providers or provider Helm, which uses the Kubernetes API, or provider vSphere or whatever, to do some operations outside the cluster. And to be able to do that, you always have to authenticate to that API. So all of the Crossplane providers have this provider config object here. You'll see here's the one for AWS. And essentially, it's just pointing to a place where the provider can grab credentials from. These provider controller pods are running, as containers. So they have file system, environment variables, et cetera. They also have access to Kubernetes secrets. We've typically just used Kubernetes secrets, and you can see that's kind of the default we have here to supply credentials to these providers. And so you can just create your secret here in the Kubernetes cluster and then consume that via the provider config. And essentially, what the provider controller is going to do is just contact the Kubernetes API server, ask for that secret, and then use it to talk to the AWS API. That's great, but there's a number of situations where this isn't super viable. So notably, that would be, if you are in a setting where you can't control the storage of your secrets, right? So your Kubernetes secrets are being written to etcd. So if you're not, encrypting your etcd cluster, or some hosted offering is providing your etcd cluster, you may not want to write sensitive credentials like this to Kubernetes secrets. Also, just them existing in the cluster, you have to be cognizant of putting the correct RBAC around that, so other users of the Kubernetes cluster are not able to access those and get those sensitive credentials. So for some organizations, it's just not viable to use Kubernetes secrets. And so we wanted to enable some other ways to do that. In the past, we've already had some specific provider solutions for doing that. So, for instance, I'll jump over to provider AWS, because this is one that we see a lot of folks using when they're running on EKS. And that's using IAM roles for service account, or IRSA. And there's some links to documentation on that here. But essentially, what that does is you put an annotation on the controller, and the AWS EKS mutating webhook is going to drop a token that allows you to get credentials from the OIDC provider. And there's a number of steps to set that up here. But a lot of folks have been using that, and we call that source injected identity. And once again, as I said, all of these provider configs, or all these providers provide provider configs. And that is consistent because of Crossplane runtime, where we define some common types. So this is similar to how Kubernetes provides like the object meta type, that has things like the API version, kind, metadata, etc. We also have a few embeddable types that folks use and generate their CRDs from. So I believe this would be in resource. And let's look at provider config. And this was just recently updated to include some more. But you can see that if we go down a bit, here's our resource spec, which has the provider config reference, and our provider config here, which has a, that's provider config usage. Let me grab this. Common credential selector is what we want. So previously we supported none, secret, and injected identity. So what's new in these upcoming releases is the ability to use environment and file system to extract these credentials from those locations. That may not seem like a big change, and functionally it really wasn't that big, but what you're going to see today is it allows you to consume secrets from a lot of backends that use things like the Vault mutating webhook to put a sidecar on the controller container and inject things into the file system. And that's exactly what we're going to be looking at today. And if you have your own solution, right, any way that you can provide credentials are pretty much going to be valid for all of our providers moving forward. So if you have any questions about that, or are a provider developer and want to know how to consume this, definitely feel free to drop some questions in the chat here or follow up with me afterwards. We do have some common methods that we provide in Crossplane runtime as well to be able to do that. So I'll show briefly what that looks like. Let's see. So this common credential extractor here is basically saying, for common types like secret or file system or environment, if you just pass this resource common credential extractor, we'll handle getting it from the file system for you. So not a ton of functionality, but kind of nice if you don't want to implement that over and over again. If you have multiple providers. If you are using something like the injected identity that may be specific to the provider you're using, in this case, AWS, so you probably have to implement something custom there. All right. So what we're really here for, though, is to look at this new Vault credential injection guide. And this is heavily adapted from some of the guides on the Vault website, specifically Vault on Minikube and the Vault Kubernetes sidecar guides. And Vault has a wonderful website here for learning things and going through different tutorials. So would definitely encourage you to check that out if you're not familiar with these concepts. We're not going to go too far into them today, but we will see them a little bit. But this definitely goes far more in depth than we will. So shout out to the HashiCorp folks for having a nice guide there. So the first thing we need to do is go ahead and set up a Kubernetes cluster. And like we frequently do, we're just going to use Kind to do that on my local machine here. And while that's coming up, let's take a look at what we're actually going to do in this guide. So the first steps here are installing Crossplane and setting up Vault. Then we're going to go about creating a GCP service account, which is going to let us use provider GCP to talk to the GCP API. Then we're going to actually store our credentials in Vault. And I'm just getting the creds from the service account we're creating and putting them in the KV store. And when we get to this point, I'll probably jump over and look at some of the different secrets engines that Vault has, because this is a very simple example where we're literally taking the credentials file and copying it into the KV store. This is even more powerful if you actually use the secret engines that Vault implements for these different cloud providers. The reason why we don't do this in this guide is because this is kind of generic, right? It could work for any provider, as opposed to those specific ones for the different providers, which we may also add documentation for. We'd have to have separate guides for setting that up. All right, so I'm guessing we have our cluster ready. Looks good. Let's go ahead and clear that out. Make sure everything's good. All right, it looks like everything is up and running. So what we want to do here is start off by installing Crossplane. And since these are kind of unpublished docs right now, this says to use the stable version because by the time this goes stable, this will be enabled. But right now, we're actually going to use the master version of Crossplane because that's where this functionality is included. So there were some changes that happened in core Crossplane to enable this. And we can talk about what those look like. You can see that the latest Crossplane version from the master channel is this 1.1 RC. So that will be coming up. But I want to show you also the resource that we're going to use to enable this and what changed in core Crossplane to be able to do that. So let's look at Crossplane. So we have this controller config resource. And basically what this allows you to do is when you install a provider, you can reference a controller config, which is basically just going to modify the deployment of the controller pod. And so you can do things like set environment variables, set the image pool policy, pretty much anything you'd see in a pod template spec. And you'll notice here that it mentions that the labels and annotations are passed to the deployment and service account. So if you actually put annotations on the controller config itself, those will be passed along. However, in this case, and in most of the cases where you're doing injection, you're going to want those to actually be on the pod, right? So if you have annotations on a deployment, it's not going to automatically be passed to the pod. You have to actually put them in the metadata in the pod template spec. And if you want to see how that's happening, this is really not magic at all. We can jump over to the actual code just in case folks are interested in adding additional things here. In our revision controller here, we basically just construct a deployment, and then anything you pass in the controller config that's referenced, we just override those values. So specifically, what we're overriding here is the annotations on the pod spec template, which would be here. All right. So I believe where we're at is installing the master version of Crossplane, and we're just going to use the latest RC that we saw there. So I'll plug this in, and we'll use this version. And that's going to install Crossplane into our cluster. And while that's coming up, we can go ahead and hop back over to the guide here and install Vault. And I already have this HashiCorp Vault Helm chart repo here. So an important thing before we do that that I want to mention is here we're setting up Vault to run in the same Kubernetes cluster as Crossplane. You could also have an external Vault instance that you are, running on a VM or running in a separate Kubernetes cluster or something like that, and still enable Kubernetes auth, which is how we're going to be able to inject these credentials into the file system. You could still enable that for the cluster that Crossplane is running in. So you definitely don't have to install Vault here. You would have to have the mutating webhook to do what we're going to be doing in this guide. And for simplicity, we're also installing Vault here as well, but just want to note that you don't actually have to do it that way. So let's see that Crossplane is up and running. All right, it looks good. So now we're just going to go ahead and install Vault. So that should be in the default namespace. And you'll see that these are pending and container creating. So in order, well, let's first talk about these two different pods that are running. The Vault agent injector is the actual mutating webhook that is going to observe the annotations on our pod for our controllers and say, okay, I need to mount the init container in the sidecar that actually puts the credentials into the TempFS volume mount on our controller pod. And then Vault 0 here, since we're not running in a high availability configuration, is the actual Vault instance. So once again, it's possible that you could do this with just the mutating webhook or the injector here, and then have Vault set up with the external authentication as well. So those should be going. All right, looks good. Next thing we need to do is go ahead and unseal Vault. And I tried to be pretty liberal with the links here. So for instance, the different concepts in Vault, I imagine that most folks that are going to be interested in using this are already familiar with Vault or already using it, as it's a common secrets engine to be using. But I do try to link to relevant concepts such as sealed and unsealed. And so when you're going through this and setting it up, you can feel free to check out that documentation. And it looks like Nick has dropped some helpful comments here. The Helm chart allows you to install just the webhook to the K8s cluster. Yeah, absolutely. So Nick's pointing out that there's actually lots of configuration if you look at the Helm chart repo that we just installed there. So things like setting up console with it, things like running in high availability mode where you have multiple Vault nodes, or just deploying the mutating webhook. Yeah, but just running Vault on K8s is also a pretty easy experience, which hopefully we'll see today because we're going to run through actually doing that. All right. So the first thing that we're going to do is go ahead and get our cluster keys from Vault here. All right. So we should see. Oh, I actually want to do that in my assets. Oh, I have to actually hold on. Let me copy that over. I'm going to do everything in this assets directory. So let's see, TBS episodes, and this is 26. And let me make sure it's here. Yeah, perfect. All right. Sorry for the delay there. All right, and the next thing we're going to do is take our Vault unseal key from those cluster keys that we just got, and we are going to use that here to go ahead and unseal Vault. An error attempting, let's see. Well, actually, it doesn't matter because I'm running it locally. Let's see if I had an issue getting the Vault unseal key. Yeah, it looks like that's not set. Let's see, I might need to actually be port forwarding this. Let's see. Where is my port forward here? All right. Let's try it with that. I don't see why I would need to do that, but Vault is already initialized. Cluster keys. All right. So there is my very secret keys. I guess I just didn't copy them over correctly. That's strange. Oh, that I know what happened. Let's take a look at this. So I'll remove that, and here they are. Cluster keys. Let me just move these into my assets directory. Move cluster keys into assets. All right, there they are. Do not share these cluster keys with anyone, but we are running on a local machine, so it's going to be fine. All right, so back up to where we were. Okay, now I should be able to get my Vault unseal key since I don't have the empty cluster keys. What I had done there was when I requested them again, it just created an empty file. And I thought that was the one I had copied over, but I was a directory too high. All right, so now we've unsealed Vault, which basically means it's able to decrypt things from the physical storage. It starts off sealed, which means it cannot. So you have to unseal Vault to be able to write and read things from it. And the next thing we want to do is get our root token here to be able to log into Vault as the root user. So once again, in a production setting, we recommend that you set up, different users and that sort of thing, but we're just going to do everything as root here. Once again, also, this is not a publicly exposed cluster. This is just on my local machine, so I am going to expose my root token here, and it's all going to be okay. All right. So let's go ahead and exec into Vault here. And then I can do Vault login. And I want to use this token here that I just emitted. All right, so I am logged in, and that looks good. And the next thing I want to do is enable the Kubernetes authentication backend. So let's talk about this a little bit. And it looks like I also might have just gotten a message in Crossplane Slack, so I want to keep an eye on that as well in the general channel. Looks like it is unrelated, so should be good to go here. All right, where were we? So we were talking about the Kubernetes auth method here. So there are a variety of authentication methods that you can use to authenticate to Vault, right, and get things out of different secret stores. This Kubernetes one is super handy. It's using the token review API. So if you're not familiar with that, it basically allows you to authenticate using your service account token. So there's all kinds of docs here on authenticating, and you can read about all the different ways. But this is just an easy way that Vault makes it possible for you to authenticate based on the service account that's mounted into the controller pod and actually the Vault sidecar in this case, which is actually going to be communicating with Vault for us here. So we're just enabling that, and we're going to be setting it up as well. Another thing to note here is when we set it up, we're actually going to be using values here in the Vault pod itself, right? So once again, you could run Vault somewhere else, but if it's in the same cluster, we already have the appropriate credentials here mounted. And so we can just pass those into our Kubernetes authentication config. So I will stop talking so much and actually do things. So once again, these are all already in the file system of the Vault pod that we are, or the Vault container that we're interacting with right now. And it looks like that our Kubernetes cluster is set up appropriately now. Let me hop back over to YouTube streaming here. All right, looks like we're good. Okay, and now we're going to leave the Vault container and start doing some things actually in our cluster. So Vault is all set up, and the next thing we want to do is start with some Crossplane stuff. So I already have a GCP service account set up, but I'm going to go ahead and go through setting up one here anyway, just to make this a little bit easier for folks to follow. So we'll set the project ID. I'll use the familiar Crossplane playground here. This is just a little script that we have. It's the same one that we use in the other setups that we do. And I believe we actually have an automated script for this as well. But essentially here, we're specifying project ID and the service account name, which I'm going to say TBS Vault demo. So I know to clean this up later. And then we're going to use this with gcloud here to be able to actually create my new service account. All right, so we created my service account, and I'm going to give this just the ability. Well, actually, this is just enabling the service within GCP, but you'll see here that I'm actually just going to give this the ability to manage Cloud SQL databases because that's what we're going to provision today. But depending on what resources you want Crossplane to manage, you might want to do other ones. I'll do this step, even though I know that we already have this enabled in this project. And then we'll go ahead and assign this role to my new service account. And cool. And let's see here. Let me switch back over. And the last thing I want to do is go ahead and create a creds.json file with my keys in it. Let's see. I don't think that was sensitive, but I'll make sure to clean it up anyway. Okay, so now we have our creds.json file here as well as our cluster keys. So we are going to go ahead and copy that into the Vault container file system. There's a variety of ways you could do this. In fact, I mentioned some of them here. You could use the Vault HTTP API, or you could port forward and use the API like this. So I'll show you what that looks like in the browser. Localhost. You'll see that it already remembers. So you could go in and use Vault here. And once again, this is just local. So let me grab that Vault token again. Can't remember what the command was exactly. Yeah, root token here is what I want. It's actually handy now that I had this up here. So I'll use this cluster keys token and we can look at what the UI looks like. So if you prefer to go through this guide, the next steps of it with the UI, that might be a more pleasant experience. But it also kind of helps illustrate how Crossplane is working under the hood to do it, actually just execing into the pods and that sort of thing. All right. So we have our service account ready. We have our creds.json file. Like I said, I'm just going to mount this onto the pod here. I guess we'll close this. And so that should be in the file system of the pod. And so if we exec back into that now, we'll be able to see that it's present there in the temp directory. So let's look in temp. So there's our creds.json. And what we want to do is go ahead and enable the KV2 secrets engine. So once again, this is just the kind of default second generation key value storage. And if we actually do that, and let's see, I stopped port forwarding. 1 second. Let me grab that again. And I'll do that from the top one. just so we can see things in the UI as well. But I believe we should see in the UI probably the secrets path enabled here. Oh, it's going to make me log in every time. I really would rather not, but oh no, we have it up there. Nice. Okay. Okay, yeah. So we have the KVV2 secret engine here at the secret path. And if you want to look at, and I alluded to this earlier, the different secrets engines, which there's kind of two types of plugins. You can actually write your own plugins if you like, but most of the common ones are already handled here. But you can see that we have our various secret engines. We're using the KV version 2 here, which is just plain key value storage. But if you wanted to actually use AWS, Azure, Google Cloud, et cetera, directly, Vault can be a conduit to do that. And maybe actually after we go through setting all this up and show provisioning resources, we'll go take a closer look at how you can use these native ones directly. All right, so I'm going to take that file and drop it into this path in our KV store, and then go ahead and just delete it. So looks good. And I believe we can go ahead and delete that file now. And there's a few other steps we need to do. So we have this in our KV store, but we need to be able to specify who can get that from the KV store, right? So right now we're logged in as a root user, so we're able to kind of like do whatever we wanted. And if you see in the secret store here, we now have our provider creds and our GCP default, and you could put as many things in here as you wanted. But we want to scope down who can actually get these specific roles. So in this case, we're going to pretend that we have this provider creds path where we put the default GCP credentials. And we are going to create a policy. So this is similar to probably a lot of IAM policies you've written. It's just Vault's flavor of that. We're going to write a policy for this path here, and we're going to call it provider creds, and basically say anything under this secret provider creds path here, roles that have this policy associated with them can read and list from it. So let's go ahead and do that. All right, success. So that policy exists, but we need to have a role that's associated with that. And then we need to somehow associate that with our provider pods that are going to be running in the cluster. And that's what we're going to do here. So we created our policy, and now we're going to create this Kubernetes role. And there's some really handy built-in ways that you can scope down who has this role. I particularly thought that we were probably going to have to specify each service count. And we actually dynamically generate these service counts for providers that are installed and upgraded and that sort of thing. So unless you override it with Crossplane, it's not a great experience. But Vault actually allows you to go ahead and scope by name and namespace. And you can use wildcards in that as well. So here we're saying any service count in the Crossplane system namespace can assume this provider creds policy, and that has a time to live of 24 hours. So I'm going to go ahead and write that. And definitely, once again, I don't know if I linked to documentation on policies here, but there's some great documentation on creating your policies and roles. I do actually link to the policy up here. Yeah, so you can read about how policies work and how they can integrate with different authentication and users and that sort of thing. So definitely make sure to lock that down to the most secure configuration for your organization. All right, so Vault is all set up and ready to go, and we have our credentials in there. And the next thing we want to do is install provider GCP. So I mentioned here, and this renders a little strange. I'm just now realizing. So we might actually have to hop over, and I'll make that correction after this show. But it looks like our website rendering is not showing the full thing here. So let's go ahead and just go to the markdown and make sure that looks okay. Yep. Okay, this looks better. So it was truncating this data here, which we'll talk about in just a minute. But basically, we're going to install provider GCP with this controller config. And a lot of times folks will go through installing provider GCP by doing kube control, crossplane, install provider, crossplane provider GCP v0.16.0. We are not going to do that because v0.16.0 doesn't actually exist yet. We need to use the latest version of provider GCP, which will 0.16.0 will have this functionality and will be coming out soon. And then we're going to reference this vault config controller config here, which is going to put these annotations on our pod. So once again, you can look up the schema for these, but basically the mutating webhook is looking for this vault.hashicorp.com/agent inject true. And then it's looking for the role we want to assume, as well as the path we want to get the credentials from. And then one of my favorite parts about this is we have this templating language where we can make sure those secrets are in the right format we want to consume. So that JSON file was copied into KV store. And there's actually kind of a nested structure to the data that's in there because there's also some metadata associated with it that also gets injected into the file. And so what we're saying here is we basically just want to take the actual GCP service count data and render it as JSON in a file. And so we can go ahead and do that. But like I said, I need to use the master version of provider GCP. So we will make sure to do that. So I'm going to create a new file. So provider.yaml. I'll go ahead and put this in here. And we'll use Crossplane provider GCP master. All right, everything else here works good, I believe. So we can go ahead and install that into the cluster. -f provider.yaml. API version not spec. I think I missed a. There we go. Have these helpful commands that aren't very helpful when you're copying. There we go. Okay, so our controller config was created. Our provider that references that controller config is created, and we can use our shorthand package type to see that provider GCP is being installed. It's not yet healthy. And we can also just see that our controller config is here as well. Not really any data on there. It's just holding data to be referenced. And healthy false. Might take some time for this to become ready, but let's go ahead and make sure it didn't encounter any issues. Active, and we'll describe it. It's likely just having some issues. Cannot run post-established deployment at minimum availability. So let's check on that deployment. Interesting. Okay, get package. All right, so we might end up doing some live debugging here. But let's see. So it looks like it found all of our CRDs. And those look good. You can see all of our different GCP types here. Okay, get pods, and now let's get deployments in Crossplane system. See if there's an issue. All right, so it looks like we do not have ready. So let's describe. Jared says the live debugging is the #1 reason he tunes in. It actually is quite helpful to potentially watch someone else do this when you have your own issues. Or at least I definitely appreciate seeing folks do this. So maybe some folks in Crossplane Slack can gain from this. All right, failed create. Minimum replicas unavailable. Interesting. I don't see anything right off the bat that would suggest that this is misconfigured. Pod template, labels, annotations. That looks mostly fine to me. Let's see. All right, so it's still having trouble though. So what we're gonna do is just delete this deployment and and have our revision controller recreate it. So that's in Crossplane system. Actually, let's look at our package. And our deployment should get recreated here. It looks like it's still having issues. So I'm going to keep debugging this and see if I can find anything. Scaled up replica set. Failed create, replica failure. So let's look at the replica set. Provider GCP. Why are you sad? I probably just have something that I miscopied. Let's see. Admission webhook denied the request. True, invalid syntax. I know what the issue is. So the problem here is when I pass this to the echo command that we have here to be able to just copy this and paste it into your terminal, it gets sad because of the string escaping on true. So if you just put true there, it's going to say, I expect a string in this annotation, which is a map string. And it's going to say, you provided me a bool. So if you quote that, that messes up the echo of that to the kube control apply function. So when I copied that over and removed it, I need to remove the escaping of this string. And actually, when you're just doing this directly, it's fine if it's quoted or not quoted. But yeah. So that is a fun thing to run into there. But you can see now that the provider controller is creating a revision, and that revision is creating a deployment. Deployments create replica sets create pods. That's why we were able to see the provider and the provider revision and the deployment. And the deployment was saying there's issues on the replica sets. We look at that, shows us where the issue is, right? So always following the chain to find the bug there. It looks like Jared and Nick might have some conversation here. Let's see. All right, yeah. So that's exactly right, Nick. The injection was not correct, right? Because we had a bad thing there. And the template, yeah, good call, Nick. Also, I am a little delayed here, so I could totally be responding super late to stuff. So I bet if we look at this again, as Nick just called out, let's see. I bet that we're also going to see an issue. Yep, exactly right. So yeah, Nick mentioned, and he probably mentioned this a while ago, but with a delay on the stream, I just got to it. We were also escaping these quotes here. We all love being YAML engineers. All right, so now we should be in a better state here on the next reconciliation of this provider revision. It's going to see that the controller config changed, so it's still figuring that out. But let's look at our deployments. All right, so that deployment is healthy now. So now that we've gotten all of our quote escaping figured out, then we're good to go. And Nick says we should work with you folks to make the process easier for you. Yeah, absolutely. I will say, I think it is a really good model. I definitely enjoyed getting this set up and adding the functionality. The quoting thing is kind of just a guide thing, right? Because we want to make it easier to apply that. But what we're going to do is put some of these controller configs in all the different provider documentation. So be like, if you're using Vault, here's just your one-step deploy to make that work. And we would obviously make sure that those were quoted properly. Jared says similar chain of debugging with XRC XR manage resources. Yeah, that's a great point. With that abstraction that we looked at earlier on, there is kind of this chain of looking at the claim and then looking at the composition and then looking at the managed resources that happen. And it can be kind of difficult to figure out where the issue is there. But that's where really great tooling can come in and make this a little easier. So we're not just running vanilla kube control commands. All right. So this provider vision is now healthy. So that is great to see. And let's look at the package and make sure it looks good too. All right, yep, installed and true. So that is great. And we should see that all of our CRDs are there. And since it's running successfully, that likely means that the Vault injection of the secret worked quite well. So let's look at the pods in Crossplane system. Okay, so we have our provider GCP one here, and you'll see, usually you'll see 1 out of 1 here, right? We're running the controller container in this pod, but because we have the Vault injection, we actually also have that sidecar running as well. So if we actually want to take a look at that, we can go up here and see we have the init container, which is getting all this set up. And let's see, here's the actual Vault agent running. And then here's actually Crossplane's provider GCP controller. You'll see that we're running the latest, which is 0.16 RC 0.9. And if we go up, we should also see that we have our Vault secrets mounts here. And if we go up even further, don't want to pass it. Our Vault secrets mount on the, I'm guessing this is the provider GCP pod. Or container, sorry. Actually, that looks like that's probably, yeah, provider GCP controller. And here is our volume mount. We have our Vault secrets path here. And so basically what's happening is the sidecar is able to talk to Vault, right? And they're sharing a tempfs volume here. So it's just storing it in memory. And you're able to, or the sidecar is able to communicate with Vault based on, the requested secrets and those annotations that we provided, and put those into the file system of our container here. Let's see. Nick says, the nice thing about the sidecar is if you're using dynamic secrets with GCP Vault, you will generate a short-lived credential and will also auto-renew. That's a great point, and definitely that was kind of what we were alluding to earlier with those different actual cloud provider-specific backends, and that is a much stronger security model and a lot easier to use, right? And you're going to get auto-rotation and all of that. So it is awesome for sure. All right. So the next thing we need to do is actually create our provider config here. And this is rendered correctly, so I can just use it. But basically we're saying we want our project ID, and then now we have these new credential sources like file system, and we're going to say we want the credentials that are at this specific path in our container. And so let's actually go ahead and look into that. Exec and go here. We're probably gonna have to specify provider GCP controller. All right, now I got it for us. Yep, defaulting to container. And so we have this Vault path here that you can see. And secrets. And there's our creds.txt, right? So now we have the ability to access this in the file system of our running controller. And our provider config with this source is going to allow us to use that. Let me hop back over here. We'll go ahead and create this provider config. All right. And the last thing we want to do is actually provision infrastructure. So we're just going to create manage resource directly here, do no abstraction or composition or anything like that. And what you'll notice is we're not actually referencing a provider config. So all of our different types here, if we look at something like Crossplane provider GCP, let's just look at GKE cluster for fun. You'll see that all of these have a provider config ref where we can basically specify which credentials we want to use that are pointed at by the provider config that's referenced. And you can do some policy around this, and we're going to have some guides around multi-tenancy where you enforce which credentials are used and that sort of thing. But let's get back over here. Because we named this default, GCP is just going to use this provider config automatically, since one is not referenced directly in this Cloud SQL instance. All right, so our Cloud SQL instance was created successfully. And what we see here, oh, it's not synced. So it looks like we are having some issues with our credentials. So let's see what's wrong. Cloud SQL instance already exists. Okay, so this is a very fun Cloud SQL instance, which we can actually go ahead and fix right now. Cloud SQL instance, I believe it's 30 days that you can't reuse the same name, which is kind of annoying. But I obviously, when I was creating this guide, I did use that Vault demo name. So we'll just use a different one here. But actually, the fact that it was able to determine that we couldn't use that name shows that it was able to use the credentials in the file system. So we'll call this Vault Demo 1. Hopefully I didn't use that one already. Okay, apply F cloud SQL.yaml. Once again, copy the full thing. Didn't have to do any escaping in this one though, so we should be good on that front. You won't get to watch me debug another failing deployment. All right, so that was created successfully. And let's get our Cloud SQL instance. It hasn't been picked up yet. Let's make sure our pod is okay. It's likely just a little delay. Yeah, it looks like we're good. Yep, and so it is now pending create, you see. So basically we were able to talk to GCP and say, create us a Cloud SQL instance. And that takes a few minutes usually to spin up. But then we're good to go. And we'll also have credentials written based on what we specified. So in Crossplane system, we should see these credentials populate as they're available. And some of them might already be, I can't remember exactly the Cloud SQL pattern. Yeah, it looks like we already have some of those credentials present in this Cloud SQL Postgres SQL connection. All right. So that was a successful demo, in my opinion. But let's look a little bit at some of those things that Nick was mentioning about the different secrets backends you can use. So I haven't looked too far into this, but I'm pretty familiar with how it works in general. But as Nick said, you can kind of enable the secrets engine for GCP. So instead of using KV store and copying in our GCP credentials, which isn't really a great workflow, right? You can actually just go ahead and set up a role set to be able to dynamically generate these new service account tokens, right? So we went through using the command line, created our service account and got our tokens and that sort of thing, which was fine for this demo. But obviously that's not really going to work in a production setting where you have a bunch of different credentials being used. So you can actually have these dynamically generated, you can revoke them and do all that sort of thing. And inject them in the file system in the exact same way, right? That's one of the nice things about having a common secrets engine is that you can switch out the different backends and they're going to behave similar, right? Because they're still coming through Vault. And you can, go into your Vault instance and configure these. And as Nick said, they'll actually dynamically update as well with the static one. So if I went in here and went to provider creds and said, I actually want you to start using this other GCP account, I could just go in and modify that. Let's see. Nick said this is pretty similar process to the way the Kate's initial setup happened. Not exactly sure what that's referring to, but maybe the mutating webhook is what's being referenced there. Feel free to correct me with that, Nick. But yeah, this is definitely an awesome workflow, and I bet we're going to see a lot of folks, especially in their production use cases, using Vault to configure credentials. Let's see. Jared also says, before the top of the hour, it's running. Can you do one more summary of all the components in play here? Lots of moving parts. Yeah, absolutely. So the main things that are in play is the provider GCP, which involves a provider and provider revision. So get package will show you all the different Crossplane package types. So when we created our provider, that was actually this asset here, provider.package .crossplane.io. Oh, Nick clarifies all the secrets engines have a pretty similar workflow. Thanks for clarifying there. That's absolutely right. Definitely one of the advantages of using Vault. When you create a provider in the cluster, for the image that you reference, it's going to create a revision for that. So this allows you to be able to upgrade and roll back different versions of packages you have installed. So with a provider, you're going to get a provider revision. And you'll see here that specifies, this is actually the digest of that package image here. And it doesn't have any dependencies. And you'll see it's healthy and true. You can also do things like modify this, and we could see another revision come through. Actually, we can go ahead and try that if we want. We're actually going to be downgrading, so wouldn't recommend using master, but why not go ahead and give it a whirl. But before we do that, I want to show what's actually happening here. And so the provider revision, it handles a number of different things. So first, creating all these different CRDs that are owned by the GCP provider. So it installs those and makes sure that this provider is the only one who can own and reconcile these CRDs. So that makes sure if you install another provider that says, I need permissions on the Cloud SQL instance type, it's not going to let it do that because you could have conflicting reconciliation there. So it gives you some strong semantics there. It also allows you to upgrade, as I mentioned before. It creates a service account that gives permission to manage all of these CRDs that are brought in the provider GCP package. And the last thing it does is it creates a deployment in the Crossplane system namespace. And it's going to do this for any revision that you install. And that's going to also, result in a pod eventually getting created. And so that package type is actually going to give you all the information around all those different things. And here we just created a manage resource directly. It could get more complicated, right, if we used composition. But that's not what we're doing today. I do want to show quickly. Well, I guess the one other thing to mention, right, is this controller config. And that's basically just saying that when the revision controller, the provider revision controller creates the deployment to modify it in this way. So we're saying in the pod template, please add these annotations, which is why get pods in Crossplane system. And let's see, JSON path. If I can just do this off the top of my head, maybe. I cannot. Let's see. What is it? Metadata. That should be correct, actually. Oh, I didn't specify the actual pod. Hold on. Get pods in Crossplane system. I still might have the wrong path here, but we'll give it a shot anyway. Yep, perfect. So you can see that all of those annotations have just piped all the way down to the pod, and they're present there, which then means that the injecting webhook, which is here, the Vault agent injector, it's a mutating webhook, right? So when this comes through the API server, it's going to see those annotations on the pod and say, oh, I need to modify this pod to add the separate container here for the Vault sidecar. It also has to use a init container as well. Described in pod. Let's see if we can just get a quick view of this. And go up a little bit. Yeah, so basically you'll see that we have both the Vault agent here as well as the provider GCP container, right? And they are sharing this Vault secrets mounts here. And so the Vault agent is actually talking to Vault using this service account that we configured a role for, right, in the Vault Kubernetes authentication backend. And it's obtaining these credentials based on the annotations and putting them into the shared volume. And then our provider pod is able to read from that. Nice. Thanks for the compliments, Nick, there on the workflow. I think it's pretty nice too. And yeah, you mentioned microservice architecture. I would give a shout out to Nick. He has a great series on YouTube of building microservices in Go. So definitely check that out if folks haven't already. But I know a lot of folks already like it, so you probably are already aware of it. Let's see. Oh, what we're gonna do? We're gonna try and go to a different version of provider GCP. So like I said, we're actually downgrading here. So let's see what happens. All right, looks good. And Nick says the Vault init container is for authentication. It uses the Kubernetes service token to authenticate with Vault. Vault gives it a Vault token that use it to obtain. All right, cool. So the init container actually is doing the communication with Vault to get the token. Perfect. And let's check our package here. All right, so our package looks good, and you see that we've changed from master to this v0.15.0. And if we look at our provider revisions, you'll see that we have 2 of them now, and the master one is actually inactive. And if we wanted to look at one of the CRDs, let's look at this one should be fine. Get CRDs. And what I want to see here is the owner references. .owner refs. It might be, maybe it's full owner references. Maybe if I spell owner references correctly. There we go. I knew I'd get it eventually. But what you can see here, it's not formatted super great, but that it has an owner reference to both of these provider revisions. So this is actually the master one that was installed. And this one is the v0.15.0. And you'll see that v0.15.0 is the controller of this resource. So that's basically how we guard against having 2 different controllers reconciling it, right? So when you upgrade to a new version, it shouldn't be able to create its deployment and controller until all of those CRDs it has established controllership over. Nick says Vault policy is tied to the Vault token because Vault can internally validate to its own tokens. It does not need to keep calling the K8s API. Yeah, absolutely. Awesome. Thank you for that clarification, Nick. And thanks for joining today. You have been super helpful in just providing a lot of context that I don't have around how the Vault agent works. So that is super helpful. We really appreciate it. I know all the listeners definitely do as well. All right. So I think we've gone through everything. Maybe we'll have a different live stream where Nick could come on and we could walk through actually using the actual cloud provider backends. I think that would be pretty awesome for authentication. We could show how that works, which is likely how folks are going to use it in a production setting anyway. But in the meantime, definitely feel free to go check out this documentation. And yeah, thanks for tuning in today. I know it was kind of back to the old days of TBS, but it was fun to do another solo show and just kind of hack around. I will mention likely tomorrow, I'll probably do another one of those cross hack sessions. So yesterday I did one on using Cluster API and Crossplane together. And what came out of that was this issue on provider GCP. So you can go back and watch that stream, although it's basically just me crafting an issue for an hour. But basically found that we need to implement these resources, which are actually pretty straightforward. and we are trying to use Crossplane as the engine for Cluster API. So the folks over at Cluster API don't have to continue to maintain kind of like scoped versions of the providers we use. So this is really exciting to see. There's some great links here. And I think I might actually do a stream tomorrow morning, maybe, actually implementing these resources, maybe talking about some other cross-plane stuff that's going to be in the next release. But thank you everyone for joining. This was super fun. And I'm super excited to see how folks use Vault, as well as other secret stores that have similar models, as well as all the different secrets engines that Vault itself has to authenticate with providers. And definitely feel free to join us in Slack and give us feedback, and let us know how Crossplane can better serve you. Yeah, thanks again, folks. Have a great rest of your week and a good weekend.